The Boeing Starliner was initially heralded as a beacon of innovation in space travel, promising to revolutionize NASA's commercial crew program. However, the program quickly encountered significant obstacles that undermined its ambitious goals. Technical setbacks plagued the development and operational phases, resulting in numerous delays and increased costs. Safety concerns also emerged, with critical issues that compromised the spacecraft's reliability. Ultimately, these challenges have eroded confidence in Boeing's ability to deliver a safe and reliable spacecraft. Continuing the series of delays for the Starliner, NASA and Boeing managers have once again decided to extend the Starliner crew's stay at the ISS, bypassing the re-entry date of June 26th. Previously, the Starliner had other delays on the 18th and even on the 22nd. This latest delay marks an indefinite postponement of Boeing's Starliner's return to Earth, marking another major setback for the troubled test flight aimed at competing with SpaceX's Dragon crew. Now, NASA and Boeing's engineering team will need more time. Sources indicate that NASA considers June 30th now as a possible return date, but the agency also wants to conduct a few spacewalks currently planned for June 24th and July 2nd will now continue. The Starliner will return to Earth afterward, possibly no earlier than the 4th of July holiday. We are strategically using the extra time to clear a path for some critical station activities while completing readiness for Butch and Suni's return on Starliner and gaining valuable insight into the system upgrades we will want to make for post-certification missions, Steve Stitch, manager of NASA's Commercial Crew Program, said. In some key respects, keeping the NASA Starliner docked at the space station for a longer period will be beneficial for NASA and Boeing. They can collect more data on the vehicle's performance during long-term missions. Ultimately, the Starliner will conduct operational missions, allowing astronauts to stay in orbit for 6 months at a time. However, the vehicle is currently rated for a 45-day stay on the space station, and that clock started ticking on June 6th. Moreover, NASA's continued need to delay the vehicle to be comfortable with its performance is not optimal for its return journey to Earth. In several press briefings since Starliner docked with the station, officials have downplayed the overall severity of these issues, repeatedly saying that Starliner could return home in case of an emergency. But they have yet to fully explain why they're not comfortable with letting Starliner fly back to Earth under normal circumstances. If an unforeseen circumstance arises, even with propulsion system issues, NASA asserts Starliner retains the capability to safely return astronauts to Earth if necessary, whether serving as an emergency escape vehicle from the ISS or if any Starliner components like solar panels show signs of premature failure. Steve Stitch said given the extended duration of the Starliner mission, it is appropriate for us to complete an agency-level review, similar to what was done ahead of NASA's SpaceX Demo 2 return after 2 months on orbit, to document the agency's formal acceptance on proceeding as planned. He was referring to the first flight of astronauts aboard SpaceX's Crew Dragon ferry ship in 2020. But the Demo 2 mission did not experience problems like the ones noted so far in the Starliner's first piloted test flight. In contrast to Starliner's current mission schedule uncertainty, NASA did not set a specific return date for its Crew Dragon astronauts mission in 2020, ultimately extending 62 days due to astronauts needing to aid ISS maintenance during a period of understaffing. So, what if Starliner proves unusable? If deemed incapable of returning Butch Wilmore and Suni Williams, a fallback option would involve returning them home aboard Crew Dragon, which transported 4 astronauts to the station in March and could accommodate additional passengers in case of an emergency. Such a scenario, considered unlikely, would undoubtedly pose a dilemma for Boeing. However, NASA and Boeing officials, along with program-savvy engineers, have not indicated current Starliner issues necessitate this step. In such a scenario, Starliner's fate would hinge on various factors, including the severity of technical challenges. SpaceX's Dragon, on the other hand, stands out. SpaceX has established itself as a pillar of reliability in the aerospace sector, particularly excelling in the safe transport of astronauts during both routine and critical missions. The company's reputation for dependability in astronaut return missions is built on a foundation of consistent success with its Falcon 9 rocket and Crew Dragon spacecraft. With over 300 successful Falcon 9 launches, SpaceX has demonstrated unparalleled proficiency in both cargo and crewed missions. The Crew Dragon, developed under NASA's Commercial Crew Program, has repeatedly proven its worth through multiple successful missions to the ISS. These achievements underscore SpaceX's ability to meet and exceed NASA's rigorous safety and operational requirements, whether for ISS resupply missions or crew rotations. SpaceX's capabilities truly shine in emergencies. A prime example occurred in December back in 2022 when a Russian Soyuz spacecraft suffered a critical coolant leak while docked with the ISS. With concerns mounting over the Soyuz's ability to safely return its crew, NASA turned to SpaceX's Crew Dragon as a potential lifeline. Rising to the challenge, SpaceX swiftly launched a Crew Dragon atop a Falcon 9 rocket. The spacecraft successfully docked with the ISS and, following stringent safety protocols, safely returned the stranded astronauts back to Earth. This incident not only highlighted SpaceX's technical prowess, but also its ability to respond effectively under intense pressure, further cementing its status as a go-to provider for critical space operations. Therefore, NASA and Boeing officials are urged to quickly review the replacement mission to rescue and ensure the safety of 2 astronauts stranded in space by the Starliner. The successive failures with the Starliner capsule are indeed more serious than anyone had anticipated. The initial crewed launch, scheduled for May 6, was abruptly canceled due to a malfunction in the valve of the Atlas V rocket. This valve, crucial for regulating pressure in the upper stage, was found to be defective, necessitating a last-minute halt of the mission. Following this, the launch was scheduled for June 1st, but faced another critical issue just minutes before liftoff. A computer card malfunction in the ground launch sequencer caused an automatic hold, highlighting yet another technical flaw that needed immediate attention. Engineers identified a problem with the power supply unit in one of the ground control computers, which required replacement before any further attempts could be made. Despite these initial setbacks, Boeing managed to successfully launch the Starliner on June 5th from Cape Canaveral Space Force Station. The spacecraft, carrying veteran astronauts Butch Wilmore and Suni Williams, docked with the International Space Station on June 6th. However, this success was short-lived as ongoing technical issues continued to plague the mission. The Starliner's propulsion system experienced helium leaks, a critical problem that necessitated further investigation and repairs. These leaks compounded the delays, pushing back the spacecraft's return mission multiple times. The persistent technical difficulties and inability to fully understand and rectify the underlying problems have left Boeing in a precarious position, highlighting the significant challenges faced by the Starliner project. The issue goes beyond technical aspects. It also reflects deeper troubles in the decision-making and management processes of Boeing's and NASA's Starliner programs. The launch has already been delayed once due to a similar problem, indicating a troubling pattern of recurring technical failures. The decision to launch, despite known issues, revealed a critical underestimation of the spacecraft's vulnerabilities and raised serious questions about the program's risk assessment protocols. Steve Stitch, NASA's commercial crew manager, defended the decisions, citing a data-driven approach. However, this justification failed to address the fundamental reliability concerns plaguing the Starliner. The recurring technical failures and their mishandling pointed to systemic flaws in the program's management and operational oversight. These events further complicated Boeing's efforts to establish the Starliner as a viable alternative for NASA's crewed missions. To address these difficulties, Boeing's Starliner will face stricter scrutiny and greater challenges in regaining the trust of NASA and the public in the coming period. For NASA, the challenges of Starliner are strategically significant, especially as it currently relies on SpaceX's Crew Dragon. If Boeing overcomes these obstacles, the company could reclaim its position, providing NASA with a diverse portfolio of commercial crew vehicles and enhancing mission planning flexibility. Ultimately, a successful Starliner program would contribute to a stronger and more competitive commercial space sector, benefiting NASA by reducing reliance on a single provider, fostering innovation, and ensuring continuous access to the ISS. That's all for today's episode. Thank you so much for watching, and see you next time.